questions 1 through 4 on the 2015 grade 12 Euclid math contest. What is the value of 10 squared minus 9 squared over 10 plus 9? Well, 10 squared is 100, 9 squared is 81, 10 plus 9 is 19. The numerator 100 minus 81 is 19. Therefore, we have 19 over 19, which is 1. If x plus 1 over x plus 4 is equal to 4, what is the value of 3x plus 8? Let's cross multiply here, so x plus 1 is equal to 4x plus 16. Collect like terms, this becomes 3x, this becomes minus 15. So they want 3x plus 8, so 3x plus 8, well 3x is minus 15, and then we have plus 8. So minus 15 plus 8 is negative 7. If f at x is equal to 2x minus 1, determine the value of f at 3 squared plus 2 times f at 3 plus 1. The first thing is let's just figure out what is f at 3. It would be 2 times 3 minus 1. You're just substituting 3 for the value of x. And this is 6 minus 1, which is 5. So now let's go over here and substitute 5 for f at 3. So f at 3 is 5, so it would be 5 squared plus 2 times 5 plus 1. This is 25 plus 10 plus 1, and that is 36. If the square root of a plus the square root of a is 20, what is the value of a? Square root of a plus the square root of a is 20. So the left side becomes 2 times the square root of a is 20. Divide through by 2, and we get square root of a is 10. Square both sides, and we get a is equal to 100. Two circles have the same center. The radius of the smaller circle is 1. The area of the region between the circles is equal to the area of the smaller circle. What is the radius of the larger circle? All right, well, we can label this, that, and this are the two radii. And the first one, they told me, is 1. The second one is what we have to figure out, so we'll call it a big R. And based on what they gave me in the question, that region between the two circles would be pi r squared minus pi 1 squared, right? The area of the big circle, subtract from it the area of the small circle. And they're saying that is equal to the area of the smaller circle, which is pi times 1 squared. And that's it. So this is what we will use. Pi r squared minus pi is equal to pi. Pi r squared, therefore, is equal to 2 pi. Divide both sides by pi, and therefore we get r squared is equal to 2. Take the square root. R would be root 2. That is the radius of the larger circle. There were 30 students in Dr. Brown's class. The average mark of the students in the class was 80. After 2 students dropped the class, the average mark of the remaining students was 82. Determine the average mark of the 2 students who dropped the class. Well, the total score of the 30 students would be 30 times 80, which is 2,400. Once the 2 students dropped, the average is now 82. So now there's 28 students. You multiply by the average, and that's the total score of those 28 students. So the 2 students that dropped, obviously their score was the difference. So 2400 minus 2296 is 104. This 104 represents the sum of the scores of the 2 students that dropped the class. So if you want their average, you divide by the number of students, which was 2, and that is 52. 52 is the average of the 2 students who dropped the class. In the diagram, BD is 4, and point C is the midpoint of BD. If point A is placed so that triangle ABC is equilateral. What is the length of AD? All right, BD is 4. So since C is the midpoint, from here to here is 2, and from here to here is 2. And therefore, we can safely assume that this is 2 and this is 2 also, since that's equilateral. And they want us to figure out an interesting distance, A to D. So from here all the way to there. Okay, shouldn't be too much of a problem to do that. All we have to do is drop a perpendicular from the top down there. So now we can use Pythagoras on that triangle. But before I do that, let's label what we know. AD, of course, is what we're trying to figure out. The base is from there to there. Well, that line that in green that I dropped will divide BC in half. So that means this will be 1 and this will be 1. And therefore, the distance from there to there is 1 plus 2, which is 3. So this distance from here to here is 3. Now all I have to do is figure out that distance. Well, this is basically, I'll draw it on the side to avoid making this diagram messy. That triangle is a 30, 60, 90 triangle, basically. This is, of course, a right angle. This is 60 because that's an equilateral triangle. And this is 30. And this was, of course, B and A, just in case you're wondering what triangle this is. All right, well, the ratio of the sides are 1, 2, and root 3. And in this case, that also represents the length of the sides. So that's very nice. That means this top to bottom is root 3. Okay, that's all I need. So now we have root 3 squared plus 3 squared is equal to AD squared. So this is 3 plus 9 is AD squared. So that means 12 is AD squared. Taking the square root, we get the square root of 12, which is 2 root 3. Yeah. And there we go. That's the length of AD, which is exactly what they wanted. Triangle MNP has vertices 1, 4, 5, 3, and 5C. To determine the sum of the two values of C for which the area of MNP is 14. Well, let's draw a little diagram and see what this could possibly look like. All right, so it doesn't have to be a masterpiece. Let's just label this 1, 4. So 1, 4 is approximately here. And then that's M. And then we've got 5, 3. So 1, 2, 3, 4, 5. 5, 3 is here. And that is my N. And then 5C. Okay, so 5C. Well, C, I don't know where C is. So most likely it means that one is up here somewhere. And the other one is down here somewhere. So we'll see how it goes at the end. So this is 5C. And this one is also 5C. 1C obviously will be positive and the other one will be negative. Now, these 3 points will, of course, make up a triangle. So let's join these points and see. So the first triangle will look like this. And the second triangle will look like this, obviously. Okay, so now what we have to do is try to figure out what is the value of C, knowing that the area is 14. Okay. The area of the triangle is obviously 1/2 base times height. And what we can do is draw a line from, perpendicular line from M to the other side to represent the height. Okay, so let's label this now. M was what? 1, 4. 1, 4. And N was 5, 3. Okay. So the area is 14. We have 1/2. The base, for the first one, I'll use that as the first triangle. The base is from here to here, and that is going to be 5, C minus 3. C minus 3 will represent my base length. And then this will be the height, and that's going to be the difference of the x coordinates, so 5 minus 1. All right, so from there, I only have one variable, so I can solve this. So this will be 2, let's see here, 14 equals 1/2 c minus 3, and then that's 4. So 14 is equal to 4 divided by 2 is 2c minus 6. So 2c equals 20, c is equal to 10. Okay, so this basically was 5/10. All right, that makes perfect sense. Now we have to do the same story, but on this triangle. So again, area is 1/2 base times height. The base will be from here to here. So that's going to be 3 minus c. So 3 minus c. And then the height, which I can use that, it's pretty much the same thing, 5 minus 1. And that area is again 14. All right, so let's see what we get here. We get, I think, pretty much the same thing. This is 4, 14. 4 divided by 2 is 2, so we have 6 minus 2c. 2c is equal to 6 minus 14, so that's minus 8, and therefore c is minus 4. All right, we got our two values of c, and they want you to figure out the sum. Well, the first one is 10, the next one is minus 4, so the sum of those two values would be 10 plus negative 4, and that is 6. And that's the answer. What are the x-intercepts and y-intercepts of the graph with the equation that's right here? Okay, well, don't expand it, factor it. I think that's a little bit better of a strategy. So let's see what we can do. I think from both of those we can get x minus 2 and x minus 3. Okay, if I do, what's left is x minus 1 and x minus 4. Okay, so I have x minus 2, x minus 3, and in the brackets I have x minus 1 minus x plus 4. So this will be x minus 2, x minus 3. The x's cancel, and then I just have a 3. Okay, so I've got x-intercept, y-intercept. All right. Well, the x-intercepts are obtained when you set y equal to 0. So set y equal to 0, and let's see what we get for x. When you do that, obviously, x is 2 or 3. So x is equal to 2 or 3. So the points are 2, 0, and 3, 0. These are my x-intercepts. Now, y-intercept is when you set x to 0. So let's set x equal to 0 in that equation. When you do, you get 0 minus 2, 0 minus 3 times 3. And this is what? 6 times 3, 18. So y is equal to 18. So that y-intercept is 0, 18. And that's it. The graphs of the equations y is equal to x cubed minus x squared plus 3x minus 4 and y is equal to ax squared minus x minus 4 intersect at exactly 2 points. Determine all possible values of a. So they intersect, so set them equal to each other. As always, ax squared minus x minus 4. Okay, well, let's see what happens here. The minus 4's cancel. Put everything on one side. So I'll have minus ax squared plus 3x plus x, and that equals 0. Let's see if I can collect like terms here. Minus 1 minus a x squared plus 4x. Okay, that's pretty good. Factor out an x, and when you do, you get x squared, and then we have x plus 4. All right, so that means the first root x is equal to 0. Okay, that doesn't really help me in any way, but that's the first root. The next root, of course, is when that equals 0. So when x squared plus minus 1 minus a x plus 4 is equal to 0. All right, well, this one obviously requires a quadratic. So let's do that over here. So x will be minus b. So that looks like 1 plus a plus or minus b squared. So minus 1 minus a squared minus 4 times 1 times 4, right? All over 2a. So this gives me 1 plus a plus or minus. All right, so we got a little bit of algebra to do here. 1 plus 2a plus a squared minus 16. And this is all over 2. Simplifying it further, we get, let's see here, a squared plus 2a minus 15, all over 2. Now, this is the key of the question, exactly 2 points. We already got 1. This will give me only 1 more. That means I can't get 2 roots here. I can only get 1. Normally, when you do a quadratic, you get this plus or minus, right? It gives you 2. But I can only get 1 because 1 root here, 1 root that I already got here will give me exactly 2 roots. And each root gives me 1 point. So the only way to get 1 root here is if the discriminant, some of you know what I'm going to say, is equal to 0. That means this guy underneath the radical is the discriminant. If that's 0, this whole thing wipes out and you only get 1 root. And that's very commonly tested on math contests. So that means a squared plus 2a minus 15 must be equal to 0. Okay, good news is this one factors. Let's see here, 3, 5, positive, negative? Yeah. So that means a is 3 or negative 5. 3 and negative 5, and that are the values of a.